this section, we're going to continue with examples. There's no real punting theory and doing theoretical things. It kind of doesn't really gel for this. The best is to tackle examples so that when you've gone through this, you see some of the key concepts and how it's asked. A lot of it is how it's asked. It's actually in the phrasing of the question itself. Let us have a look here at another example. I'm going to do an example here with unknown time. Example with unknown time. We invest, it says here, we invest 1,000 units per month at an interest rate of 12% per annum, compounded monthly. Okay, I'm going to do my quick check. Green, 1,000 per month and compounded monthly. Tick, I'm safe. I can continue because my monthly little payments I'm doing and my interest rate correlate with each other. When will we have saved? When will we have saved 75,000? All right, let's do a drawing. So now I'm saying naught is now, and this is my monthly payments, correct? And it's going on for n payments. And they have asked when it's a future value equal to 75,000. When will we have? That is future tense. I'm sure the English buffs are going to tell me it's something else in or some other tense, but it's a futuristic kind of thing. That's what we're asking. When will we have saved that? And I know that my x is equal to 1,000. I've got my formula. F is equal to x times 1 plus I all to the n minus 1 all over I. And now let's put in the formula. 75,000 is equal to 1,000, which is x, and my interest is 1 plus, it was 12%, 0.12 over 12, and it's 12 times n, or n, whichever makes more sense to you. 12n is I've got that and that to be the same. Right? But remember, the n is actually, could be number of months. I am now saying that that's going to be in years. Doesn't matter. Let's just go ahead with it and see what happens. And you'll see the logic at the end is you'll ask yourself a question. All right, 75, therefore I is that. Now I'm going to solve this. I'm going to say the future value is equal to that divided by 0.12 over 12. Oops, need to go back to black. Just going to leave it as it is. My next thing is to say, okay, then 750 is equal to 1,000 times, I didn't even finish that up top there, 1,001, 0.01 to the power of n minus 1. Always take them down. Use quite a few digits there if you don't want to use memory in the calculator. That I'm now going to say that's 0.75 is equal to 1.01 to the power of n minus 1, and that's going to go across, and the end result is we're going to have 1.75 equals to 1.01 to the power of n. Take logs of 1.75 is equal to n times log of 1.01 and calculate n. N turns out here to be 56,24. But what have I got? I am now going to do it with the 12n. So I've got n, is going to be 56,24. This is months. Remember, That was to convert. So if I did 12n, I would end up with log of 1.75 equals to 12n times log of 1.01, because it would have been 1.75 equals 1.01 to the power of 12n. And the 12n would come down to the front. Therefore, 12n would be equal to 56,24. N would be divided by 12, but then it would be in years. You guys can choose. I like to do it in discount periods, not years. So I would use N as months. It doesn't matter. Obviously, you're not going to have 56 years because that's patently ridiculous, isn't it? Now, therefore, number of that, 12, 4.6 years. So basically, we need, because we haven't answered the question, we need 57 months in order for it to get to where we want to. Similarly now, the next set is we're looking at present value. That's today. Essentially, you could say if I have an annuity like this, remember we had future there, is would you take all these payments of X or would you take this cash up front? We're saying instead of P is instead of the X series paid out. Do you want your 10 million now, or do you want $1 million a month, $1 million a year over so many years? Which do you prefer? Most people take the cash up front because I suppose that's psychological to do so. Let us continue and now say, all righty ho then. This is the present value of an annuity, and you can see what you've got here is you've got P is going to be equal to X. It's all the same. 1 minus 1 plus I to the power of minus N all over I. It's exactly the same. This is where we evaluate a monthly, probably a thing like a loan. All right, I'm just going to put it there. Often we get asked, would you rather pay cash or take a discount? Pay cash or take, that was wrong. Pay cash and take a discount. Pay cash and take a discount, or use finance monthly. Well, let's take an example of this, shall we? Let's do an example. All right. Obviously, just to go up here, these are things like loans. Right? This is loans, paying back a car, a house, etc., a fancy piece of equipment, blah, 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 blah. Right, let's take an example. We can buy an asset, an object, or whatever, for 10,000. And our financing options are cash with a 10% discount, or pay over 6 months, or 6 months with interest at 10% compounded monthly. So what do I do? Well, cash, option 1, cash is equal to 10,000 less 10%, which is therefore, we're going to pay out 9,000. That's payout, isn't it? And we walk away with the object. The next one is we go for a financing. Financing, what do I say? I'm going to be paying it off every month at X, right? Don't know at this point. I equal to 10% compounded monthly, and my present value is 10,000. Because that's what I am borrowing from the bank. This is what we borrow from the bank. Let's just go through it. I want to buy this ornament, okay, this glass apple, and it costs 10,000 units. I go to the store and they get me to fill in forms, and the bank lend me the 10,000 units to buy this. I therefore owe the bank. What does the bank do? The bank pays the store the 10,000, and I then pay the bank back. Generally, stores don't fund it. It's banks. Some do, but mostly it's a bank that does it. So I say to myself, okay, that's what the bank, I owe that to the bank now. So let's have a look. Okay, what is the payment? The payment is 10, when it's finished auto-saving, is 10,000 is equal to X times, now remember it's 1 minus 1 plus 0.1 over 12, all to the power of minus 6 over 0.1 divided by 12. And we solve for X. X comes out to be 1715.54. Therefore, we pay 6 times 1715.54. How much do we? That's what we pay the bank. So we pay in total 10,293.27. Therefore, the bank makes 293 Rand interest, 293 units of interest. But basically, we saved how much? Minus 9,000. Therefore, we save 1293.27 if we pay in cash. Obviously, not everybody can pay in cash. But what have we said? We've worked out how much we pay the bank. We pay 6 installments of that amount, and therefore we have saved 1,293 Rand and 0.27 units if we went and we paid in cash. Now, let's ask another question. I alluded to it earlier. What about payments made? Now, this is payments made at beginning of a term. Now, when we look at an annuity, please just be careful. This is what we're saying. We are saying a monthly payment. This is 0. This is the end of 1 month. And this is the last month. So we make a payment at the end of every month. End of every month. We make the payment at the end of every month. That is critical. When we're looking at these problems, you must understand that drawing. Therefore, I'm going to do a further example of it. I'm going to say, a standard annuity, we've got this. So I've got this situation here, and I've got 1, 2, 3, 4, 5, 6 payments. Okay. So therefore, N is equal to 6 payments. But what if I pay up front 6 payments of X? Correct? This is now, this is the end of month 1, 2, 3, 4, 5, and 6. Call it June, July, August, September, October, November. Doesn't matter what you do. January, whatever. Now, what if I do this scenario then? I say, okay, let's leave it as black. Okay. Leave this payments here. 1, 2, 3, 4. There's the 6th. But I make a payment now. Now, maybe I should actually just put that one where that starts. I make it, Kevin. Now, you can see I have got my annuity there. This is my standard annuity, isn't it? And this payment now is a system that looks like this. This is going to have an interest rate the same, right? So the standard annuity is going to give me a future value, right? Then I must add the single payment made at beginning with interest, because this here is P and this is A. This must be done also over 6 months. There's 6 months of money that must be added onto that. That's what I have to do. Right? So I have to add it so that it actually is, it's a 1 and a 2-part problem. You can use n plus 1. You can increase it. It's just that this way I prefer it. It's entirely obviously your choice. What you do here is we split it up. Split up into standard annuity and a straightforward PA problem. 1 month payment, one payment going right to the end, and add them. That's what my future value will be. So I prefer doing it that way. And what if we have the opposite? What if we have the opposite and we defer a payment? You've heard of that. You hear it sometimes. Buy now and only start paying 3 months from now. In other words, you get your goods now, which is what psychologically I want it and I want it now. That's who we are. So I get it now. Yay. And guess what? As a bonus, I don't pay for 3 months. Everybody thinks, yay, that's fantastic. Guess what? I'm getting scoring for free. You're not. Because the bank doesn't do anything for free, so to speak. They are going to calculate it. And this is what they do. Say we borrow. Here we go. Say we borrow 10,000. Right? At 15% per annum and compounded monthly. Let's do an example. Compounded monthly. We start paying only after 3 months. Only after 3 months. And we pay 24 equal installments. So what does it mean? It means that this is now, we borrow 10,000. 1, 2, 3 months. So when do we do our first payment? This is payment 1, and we go all the way through to we pay 24 of them. Correct? Therefore, my annuity works like this. This is P of my annuity. All right? Let me just erase that. I think it might just confuse. So that's what my annuity looks like. So anything to do with my annuity, so P would be there and F is there, correct? That's my standard annuity. But now there's a little problem. The little problem is that for 2 months, I have got money that is the bank's money. So they would say, the 10,000, I am going to charge you interest over that 2-month period. We pay interest for 2 months. But we don't pay it, we add it on, we capitalize it, we add it on to the number. So therefore, this over here is P, calculate A. So I say, cool, A is equal to P, 1 plus I all to the n. P was 10,000 times 1 plus I in this case was 15, 0.15 over 12, and how many months? 2. Now I work out what that's going to be, and that is going to be equal to 10,251.56. That is the actual amount. This becomes the P for the annuity, doesn't it? Let's go and check it out. This becomes P because now I actually owe 10,251.56. They've added that 2 months of interest on. Nope, you're not going to get anything for free. Right, that's also in physics, Newton's law, no free lunch. Right, question, well, not the question. The next step is to then say, okay, is black. The next one is to say, right, then what do we owe? Then I would say, right, P is equal to X times 1 minus 1 plus I minus N all over I. P, in this case, is 10,251.56 is equal to X times 1 minus 1 plus I was 0.15, but it's monthly, so it's times minus 24. That was the number of payments. 2 years, 12, 24 payments, all divided by 0.15 over 12. Therefore, I calculate X as being equal to 497.06. Okay, check. We pay, my little side check, we pay 497.06 times 24. Total payment 11929.53. That's how much we pay. Well, that ties up because it's actually 10,251. So we pay more. That's the interest that we are paying. Now, the last one that we're going to do is going to probably take us over a little bit. But let's just have a look at it. Now we look to take a loan. Here's an example. We borrow 1 million. We borrow 1 million and commit to repay and commit to repay at a given at 32,000 per month, starting at the end of the first month. Straight away, you know that's a standard annuity, correct? Interest is charged at 10.5. Interest is charged at 10.5%, 10.5% per annum, compounded monthly. So let's just have a look at a timeline first. So I'm going to put this in here. There it is. There's my time. And I can put in here straight away, this is 1 million, and that is P because it's current. And X over here is 32,000. N is unknown. I is equal to 10.5.105. Do you see that? N is not known in this case. So therefore, we have to calculate N. How long to repay this? You can see that this is a different way of asking the same question. How long do I take to repay it? Well, we use the same thing. P is known. So we say, okay, 1 million is equal to 32,000 times 1 minus 1 plus 0.105 divided by 12 to the power of n, and n I'm just using as periods, over 0.105 divided by 12. Okay, please follow this one with me. It's very, very important one, this one. So then I can say, okay, I multiply this through there and I get 8750. 8750 is equal to 32,000 times 1 minus 1 plus. I actually, in this case, I worked out the bracket, 1.0000875 to the minus n, like that. I forgot the minus n, sorry. Kidokes, divide by the 32,000. Now you get 0.2734 is equal to 1 minus 1.00875 to the minus n. I take that 1 across and change sign, that it becomes 0.7265625 is equal to, then it becomes n log of 1.00875. I've changed the sign. Yes, it comes down as minus n, but I've changed the sign already. It was minus this. Sorry, let me just get this. This was minus, that was minus, and I changed the sign both sides again. Do this calculation. Go through it, then set it up and go through and do it and follow the way we've done it. Therefore, I come out to be n equal to 36.665855728. Okay, this you can store or use the long version. In other words, write it down long because you're going to need it. Which means that actually we've got 36.66 payments of our annuity, haven't we? So let us have a look what happens then, shall we? Let's have a look. We make 36 payments. We make 36 payments of 32,000. So let's have a look. This is 34, 35, 36. And number 37 never gets made, does it? Because we come along here. These are all of our 32K, 32K, 30. When do we actually make the other payment? The last payment here, The last payment is made at 0.66 something 32. So what we're asking now is we're asking, what is the outstanding balance? What is the outstanding balance after the last full payment? In other words, at that point, we want to know after number 36 has been paid. And we work that out as follows. We say, how much is left to pay? In other words, we say P is equal to X times 1 minus 1 plus I to the minus N all over I. Let's fill in. Okay, P I don't know, but the 32,000 was my last payment. It's this little piece here. I'm essentially bringing it back. 1 minus, what is 1 plus I? 1 plus 0.105 over 12 months to the power of minus that big number, 0.66585728. It's the balance, isn't it? That's what we're bringing back. All divided by 0.105 over 12. Which gives us, we work it out, 21,153.34. So therefore, that is the outstanding balance. I'm now going to draw it in a bigger scale. This is number 36. This is number 37. What I just said is that the green, this is the 0.66585 blah 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 of the month, correct? The outstanding balance is this P here, is 21,153.34. That's the outstanding balance. But I'm going to pay this there. Therefore, I have to add a full month interest, don't I? Which means I've got, therefore, now I've got a situation like this. Correct? 1 month, I know it's only 1 month. This is 21,153.34. This is my amount and my interest is the same. So therefore I say my amount is P 1 plus I to the N. Let's just move it up a wee bit. And my last point here is we say that is equal to 21,153.34 multiplied by 1. It's 0.105. 0.105. We just check 0.105. Need to check on that. Anyway, 0.105 over 12 all to the 1. And let me just check what that comes out to be. It's 0.105 divided by 12. Divided by 12 is that, plus 1 equals that, times 21,153.34 is going to be 21,338.43. Okay. You can check that one for me. I'm pretty sure I'm right because I did there. Oh, okay. I know what I did. I used 0.015. Okay, which is incorrect interest. It's 21,338.43. That is what I actually have to pay at the end. So this is going to be my last payment at end of month 37. So I pay 32s all the way, and then the last bit is I pay that. In the follow-up ones and in the more advanced ones that I'm going to do as examples, we'll do different ways of looking at these. But thanks for watching, and cheers for now. Enjoy financial mathematics. It really is a cool section of the work. Cheers. Have one. Great one. Bye.